Let's take a look at Neutron deployed with OVS and DVR. Take the classic example of a tenant that has an instance. That instance is connected to a tenant network, 172.31, which is a private address range. We have a router that serves as a gateway for that network, and that router has an interface on an external network also. Now, we know that a router is implemented in Neutron by creating a network namespace. Now, the way layer 3 with HA works is we will have the layer 3 agent running in your controller nodes, but it also runs on the compute node. So for each router the tenant has, a network namespace gets created on each compute node where that tenant has instances connected to the internal network that that router serves. So what namespaces do we have on the compute node as of now? We have two namespaces. One that corresponds to the router, and we have this additional namespace which we will call the floating IP namespace, and we will examine its function shortly. First, let's take a look at how the router is composed. So we have an interface for that router on the internal network, and we saw that should be 172.0.1, but it doesn't have an interface directly connected to the external network. Instead, it has an interface in the range 169.254. And this interface is called RFP because it's the connection between the router and the floating IP namespace. So let's take a look at how the floating IP namespace is composed. So the floating IP namespace also has an interface on 169.254, the floating IP to the router connection, and this guy does have an IP on the external network, in this case 203.0.113.3. Now, let's go back and let's take a look at the router, and let's examine how this guy is connected to the instances, how it serves the instance. Now, because we're working in OVS environment, we will use the OVS vsctl show command to look at the different OVS switches that are active in our environment. So we see that the integration bridge, or VRInt, has a port for this interface that actually corresponds to the router interface. Now, this is possible because OVS has a component in user space, so no need for a veth pair, as in the case of Linux bridge. So, how does the north-south traffic work between clients in the outside world and when they are trying to reach our instance that is running in our cloud? So first an ARP gets sent to determine what is the MAC address associated to that floating IP address. Now, that's the function of the floating IP namespace. The floating IP namespace actually works as an ARP proxy that will answer to ARP request that corresponds to that floating IP. How does it do this? Well, basically just by having a route to that floating IP via the router, he will be able to answer to those ARP requests. Now, packet reaches, now that the external client knows what the MAC address is, switched network would actually direction those frames into our compute node. Those packets will hit the provider bridge, then hit the integration bridge. Integration bridge will forward them to the router namespace. Router namespace will perform the NAT, and then send that back send that packet to the instance. But not before passing through a Linux bridge. Now, why Linux bridge if we're working with an OVS environment? Well, It's because OVS cannot directly interact with IP tables. So we still need that Linux bridge on the middle that has that actually performs the connection between the compute node's IP table instance and the traffic that is flowing towards our instance. So we have this chain that intercepts traffic that comes into that tap interface, directs to Neutron Open vSwitch security group chain. Security group chain right here will direct that to that instance's corresponding IP tables, rules / chains. And here we have the actual rules that get implemented. In this case, we're accepting traffic for port 22, and we're also accepting traffic for ICMP. So those should be the same rules that are active in our access and security window for our default security group. So when we do manage rules, we'll actually have a rule that accepts ICMP, another rule that accepts SSH traffic. Each of these have a return action. This will get directed to the previous chain that invoked this particular chain. We know that that chain was this one right here, which will have a directive to accept traffic. And that is our example for Neutron with OVS and DVR. Thank you very much.